Hey students, today we're going to be talking about functional groups with Mr. Halpern. And functional groups are groups of atoms or bonds that react in a very specific way depending on which atoms or which bonds we're talking about. And what we're going to do in this particular video is expose you to what they look like and then be able to name them if you see them as a structural molecule so that we can identify them. So to start off with, we're going to start with the first one. The first one is an amine, and amines are known to be really good for making dyes. Also for treatment of gas leaks and things like carbon dioxide gas leaks, amines are used. DHEA is a chemical that has amines, or is created with amines. And then finally, pharmaceuticals. Yeah, spell that correctly. There we go. All right, so structural formula for this, when you're looking at an amine, you're definitely going to have, oh, sorry, one sec, click in there. Sorry for that. So for amines, you're definitely going to have carbons, and at the end of the carbon, you're going to have a nitrogen. And that nitrogen is that characteristic atom that will tell you that you're looking at an amine. So I would just make sure that you draw this. And then you can also make sure that you draw hydrogens around this. Okay, so you can also have hydrogens coming off here. So hydrogen here, hydrogen here, hydrogen here. 2 hydrogens here, and then 2 hydrogens coming off of the nitrogen because it wants 3 bonds. Okay. All right. So examples. This one that I particularly drew here, because it has 2 carbons coming off of the nitrogen, we have a special name for this, and this is called ethyl. Kind of like it's an ethyl group, right? Off of the amine. It's called ethylamine. So when we're naming this, we're going to use the suffix amine. So blah, 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 amine. In this case, ethylamine. Okay, and I put the condensed formula over there on the right. All right. Again, what you need to remember is really the structural formula and how you can identify the structural formula and then name it based on the structural formula, and also some uses. The naming, it's not going to be important in naming these particularly, except if you have a specific name that might tell you what you're looking at. So if you see ethylamine, you know that you're looking at an amine. Okay, so for ether, ether used to be used actually as a anesthetic, but it caused some problems and ended up becoming an addictive drug, and so they stopped using it. But now they use ethers as starter fluids to help start your car, and also in fuels. So ethers have a specific structural formula. So they have a carbon here on one side, a carbon on the other, and in the middle here we have oxygen, like that. Okay, so oxygen will be in the center of 2 carbons, and you can have more carbons coming off to the right and to the left here, but noticing that within the chain of carbons you have 1 oxygen, you know you're looking at an ether. To name ethers, it's very similar to amines. You're naming the group off of the oxygen in this case, and so this is actually called, because there's 2 groups, 2 carbons off of the side, we're going to call this dimethyl ether. Pretty self-explanatory. And so the suffix that we often use is just ether for that. And the condensed formula is over there to the right. Condensed formula just helps you to see, again, sort of the condensed version of the structural formula. But you can see the methyl group on the left, and then the methyl group on the right, and the oxygen in the middle. All right. Alcohols. Alcohols are used often as solvents, but they're also used as reactants in reactions. So they help to create a reaction. When we're talking about alcohols, we have a chain of carbons typically, and then alcohol as OH at the end. So we'll put dash here, and then we have oxygen and hydrogen. All right. And by the way, the ether too, if I was to add, the lines there, the ether would also have, it's a methyl, so you have 3 hydrogens coming off of the carbons here on either side. Okay, just so you're aware of that, right? Same thing with the alcohol. The alcohol is going to have 1, 2, 3 coming off here, 2 here, and then this oxygen is actually covalently bonded, just one bond to the hydrogen there, even though I put the OH together. That helps you to know that there's an OH, and so they're talking about an alcohol here. All right, so naming this, all right, this is a specific name. It's called ethanol. All right, because there's 2 carbons coming off, so it's ethane basically. But instead of an ane at the end, you have an OL because it's an alcohol. So the ending will always have an OL for alcohols. All right, so for aldehyde, aldehydes are actually used as flavorings and adhesives. So that's kind of cool. Aldehydes specifically have they have carbons here, and I'm going to just draw them down here specifically. So they have carbon, and then they have another carbon, and then they have oxygen, but the oxygen at the end here is a double bond. Okay, so again, you have your hydrogen, or I'm sorry, your covalent bonds here coming off, but at the end of the molecule you have a double bonded oxygen there. So this is an aldehyde, and aldehydes are named with, again, their group of carbons, so ethan, and then it's al, ethanal. Okay, and it has an al ending. And the condensed version is right there on your right hand side, CH3, CH, and O. Ketone, I love that word, ketone. It's very similar to aldehydes. It's used for flavorings and adhesives. But ketones are a little bit different. They have a double bonded oxygen, but instead of it being on the end, it's going to be kind of in the middle of the molecule. So you have a carbon here, and you'll have a carbon here, and you'll have a carbon here, and a carbon here, right? And these are all bonded together, all happy. But in a ketone, one of the middle carbons, instead of the end, will have the double bonded oxygen there. Right? You'll have hydrogens all around these carbons, right? Not this one because it already has 4 bonds. This one and this one. Okay, but that oxygen is bonded to a middle carbon rather than one of the outside carbons like an aldehyde does. So that's why we distinguish it as a ketone specifically. So ketones have a special kind of name, and in this case, this is a propanone. and so the ending is ONE. Oh, huh. It was missing. And then so it's an ONE ending. So ONE for ketone. Right, that kind of makes sense. Right, we have ketone here. Aldehyde has Al, right? Alcohol has OL at the end. Ether is just its actual name, ether, and amine is just its actual name, amine, to name them. Okay, so carboxylic acid. Carboxylic acid, it has special uses. They're actually used for in preservatives, or as preservatives, so preserving foods and things. And it's also used as reactants, like alcohols. In terms of the structure of this, you have, it's at the end, this functional group is at the end, and I'll draw it here. So if you have a carboxylic group, you're going to have a double bonded oxygen here, but then you're also going to have an OH at the end as well. So it's almost like it's a combination of sort of an aldehyde, because the double bonded O is at the end, but it's also an alcohol too, because it has the OH there. So when it has both of them, the double bonded O at the end with the OH, you're going to have a carboxylic acid. Again, I'll just put little sticks to represent the other covalent bonds there. I just added too many there, so it's just these three that you would have. Okay? Alright, so the name of this, add this in here, is ethanoic acid. And the suffix at the end, therefore, is oic acid. So every time you see oic acid, you'll notice that it's a carboxylic acid. Last but not least, we have esters. Esters are my favorite kind of functional group. Last but definitely not least, these are used for artificial flavors. And fragrances. They're often used, you'll see them always in like bubblegum flavors and fruit flavors. They actually have like a lot of fruit flavors. We're going to actually make those fruit flavors, and you're going to smell the esters that we're making. Also, they're used in clothing, polyester. Polyester is just many esters bonded together. So what is an ester? An ester is where you have, draw this here, an ester is where you have a carbon bonded to another carbon, and then instead of the double bond being at the end, it's actually in the middle. And instead of having an OH, it's just an O, and that's bonded to another carbon over here. So sort of in the middle of the molecule, you have a double bonded O and a regular bonded O, single bonded O, oxygen. And so notice the difference between this versus carboxylic acid. Carboxylic acid has an OH, and that's at the end, versus the ester. Okay, notice the difference between this and, say, a ketone. A ketone has just a double bonded oxygen, but an ester has a double bonded oxygen and an oxygen, another oxygen, so two oxygens there. Alright, and so this is esters, and so this is actually called, oops, I'm not sure why that goes away, but this is actually called methyl propanoate. spelling this incorrectly. Propionate. And the ending is always OATE. Okay, so those are the different functional groups and their names, their uses, their structural formulas, an example, and suffix for you to look at. So we're going to practice this. So functional groups. This functional group here, and the functional group that we have here is to, we have multiple examples here. One is butaxolol, and this is another example over here. We have acebutolol, and these two are beta blockers, and beta blockers are often used to lower blood pressure, to lower your heart rate, and to stop things like angina and reduce risk of heart attacks. So very, very helpful, these drugs. They have multiple functional groups on them, so we're going to label them just with like circles here. Alright, so the first one I'm going to circle is this one. Alright, so can you tell me what that one is? It's actually the same thing as this one. Alright, well, it's an oxygen that's bonded kind of in the middle of the molecule. And so we're looking up at our group here, and I see that there's an oxygen here, right? This oxygen right here is bonded in between two carbons. It's kind of in the middle, so these are ethers. Ethers, right? So I'm going to put these as ethers. So this is an ether, and this is an ether. Alright, what about this one over here, this funny looking shape? What about an OH? What has an OH at the end? Well, there's an OH and there's no other carbons at the end, so if it's just an OH, it's an alcohol. Alright, so this is our alcohol. That's an alcohol right there. What about the nitrogen and the hydrogen there? There's nitrogen, so, I see that nitrogen is there. It's an amine. There's only one functional group that has nitrogen in it, and it's amine, so it's pretty easy to remember. Alright. Some other ones that you can also label, we can also label these parts here. You just learned about this one, right? This one is actually a aromatic. It's called benzene. And it has double bonds in the middle, so it's definitely not a cycloalkane. This, however, at the end, this triangle is a cycloalkane. This is a triangle, and the specific name for this triangle is cyclopropane. Right? The reason why it's propane is because it has 3 carbons around the outside there. So it's a cycloalkane, specifically cyclopropane. Just naming the groups here. Alright, moving over. Alright, let's try to label these other ones over here. Alright, try to label all of them, and we're going to come in and talk about it. The second video that I'm going to do, I'm going to explain the problems on the back. And if you're really, really interested in getting ahead in the videos, you can do the back. It's just examples of different functional groups. So you just have to name what the molecule is. Is it an alcohol? Is it showing a ketone or an ester or an ether? Okay? All right, take care.